There's a lot involved, of course, and mostly it's involving maintenance. And when we look at the different maintenance regimes, we see that, of course, traditionally, a lot of companies still look at reactive maintenance, right? But as you probably also know, and it's well commonly known, is that reactive maintenance is very expensive. So we are seeing a shift to other regimes like preventative, predictive maintenance. However, if you look at any oil lubricated equipment and you look at the machinery lubrication related to that, we are really looking at a more proactive maintenance. Because maintenance, where does the name come from? Well, to maintain, right? It comes from the verb to maintain. So it's actually the maintenance activity is to ensure that your equipment, your assets, keeps on working the way it was designed with the same power output and of course performance as it was designed to do so. So yeah, if you look at reactive maintenance, is basically doing nothing until it breaks, right? And if you look at machinery lubrication, is actually proactively taking care of not only the in lubrication. Dive into W or Flender and other companies that make hydraulic power packs. And in the perfect world, they are designed to last, well, 25, 30 years, or maybe even longer. And of course, if they would be operating in a climate controlled environment under the perfect circumstances, they will last that long. However, if you look at the reality is a lot different from that. In different industries, you see that the equipment is operating under very harsh environment conditions, with heat, with dust, dirt, with humidity, and such. So by far not a perfect world, let's say. And what you also see, of course, in the environment conditions under the heat and sunlight, equipment and components start to deteriorate, and of course impairing with the functionality of systems. So what we see is that there's with any oil lubricated equipment, there are several challenges, right? Because they are operating in extreme ambience and process conditions. They're often working 24/7, high speeds and lows, high temperatures or low temperatures, high humidity, contaminated air in the environment, etc., etc. And on the other hand, you you have to realize that, let's say, a centralized lubrication system is there to ensure that clean and dry and cool oil flows through the components to the bearings and is able to lubricate them properly. Um, and if you look at, for example, a hydraulic system, it's sending out the oil through the system to ensure productivity and efficiencies. And of course, it's also there to avoid premature component failures and system. There's under these circumstances, there's a lot of challenges for these oil lubricated equipment. So what happens in practice is that the oil is still seen as a consumable. Companies just replace it as if this, yeah, again, as a consumable. But yeah, therewith it doesn't receive the attention and it deserves and actually requires, because you have to realize that the oil is really like the life fluid of a system, right? It's like the blood of the human body. If you are as a human, if you go to, let's say, McDonald's 3 times a day, 6 months in a row, what will happen? Your kidneys and your liver, etc., cannot clean your blood anymore, so you get contaminated blood. You get buildup of cholesterol in your veins and blood vessels, and of course that will impair with the functionality of your body. You will feel sick, get sick, and maybe have a very catastrophic failure. Now that's actually the same with oil. So it'll do, and at first it's on microscopic level. We don't see it, but it is there, and it's doing a lot of damage, and that gets worse and worse. So as long functional failures. And lastly, of course, you have to realize that a gearbox without lubricant will damage, will break down very soon. And a hydraulic system without oil, well, it doesn't even work. So can have the very expensive cylinders, best pumps and valves, etc. But without oil, it will not do anything. So it's very important that you as end users, or your clients, that really start to have to look more carefully at the oil, give it more attention, and get the contamination under control. Here you see an example of a top-off done with a Coca-Cola bottle, oil in a Coca-Cola bottle. No idea what kind of oil is in, and of course this is not really machinery lubrication best practices. So we talk about contamination. What is contamination? Basically, contamination is anything that doesn't belong in the oil. And yeah, then the next question is, of course, how does this contamination get into your system? Well, let's have a look at for example, a hydraulic system, and then the main part first. So a main part of a hydraulic system or centralized lubrication system, of course, it has a pump, it has some filters, it has a vent connection to the environment, and often a heat exchanger. So a vast majority of the ingress of contamination of particles, micron-sized particles, and humidity is through the vent. How does that happen? Well, anytime that your cylinder goes in or out, especially, you'll see that there's a fluctuation of the oil level inside your reservoir. And let's say your cylinder goes out, so the level goes down. So that area in your headspace, what was with oil, now will be replaced with air. And where does that air come from? It comes from the environment. So if you don't protect that, which is a very common thing that happens in the field, then you're actually pulling in, every time the level goes down, you're pulling in contaminated oil or air. Sorry. Humid air turns into condensation when the system cools down. This condensation is basically water droplets. It can either corrode the inside of your headspace of your reservoir, and or fall as water droplets into your system, so contaminating your oil. That gets worse and worse, and of course, then the oil gets very contaminated with water, and as we'll see later on, then you get emulsified water, and that is also very devastating for your systems. Another ingress point is contaminated new oil. New oil should be chemically and physical properties should be according to specs, of course, but as you may have seen already, if you take a sample from a new oil drum, you'll see that it's already outside your target cleanness level. So by doing a top-off of a gearbox or a hydraulic system, and not doing any pre-filtration, you're adding contamination to your system there. Another very, very high contamination ingress point is also adding the wrong oil. There are different oils with different viscosity for a reason, and that's because the viscosity defines the film strength and the film thickness. So if you put a gearbox oil into a hydraulic system or vice versa, you are generating a lot of issues. If you put a hydraulic oil with let's say ISO VG much weaker, much thinner. So then you have metal-to-metal contact in your gearbox, and your gearbox teeth will get damaged very soon. So what we see in practice, adding the wrong oil happens a lot. And that all starts in the lube room, which we will touch later on. Of course, some components may break down, some hoses may burst, or some piping may leak. So then what we do, we replace those failing components. But in practice, these components are not properly cleaned on the inside. So maybe you have cut some piping to fit into the system, and you do some grinding, etc. So there's all these particles that potentially stay inside the tubes. and then when you connect it to your existing system, you're actually adding a lot of contamination. And fatigue happens, of course, from these micron-size wear particles that will generate more wear and more particles and wear. So internally generated contamination and wear is very high as well. Lastly, what we also see is heat exchangers. They tend to leak. Sometimes just a couple of droplets per day. Sometimes there's a rupture, and then you have a significant amount of oil or water in your oil, which does a lot of damage. If we look at the cylinders, of course, the cylinder rods, they have seals, but these seals are not 100% tight, and they also get damaged. So what happens if you, especially in a harsh environment, humidity and particles stick to the rod, and as soon as the cylinder goes in, it's pulling in all that contamination, and it stays, which is staying into your system. Internally generated wear in your valves. Your valves have very tight clearances, and we're talking about maybe a couple of microns. And if you have a hard sand particle between these moving parts, it will create scratches, micron-sized scratches on the surfaces, internal surfaces. And of course, these particles will stay in your system, will flow back, and then again damage more and more and generate more wear. And like we've seen before, is also solid contamination through repaired components. Gearbox, basically the same story. Of course, there's no really level fluctuations of the oil, but there are temperature fluctuations. So also there, to avoid of pressure or vacuum in the headspace, there's also a vent. There's a connection to the environment, and then when there's temperature fluctuations, so let's say the gearbox has been running the whole day at 60 degrees at night, it stops, and of course the ambient temperature gets very low, cools down within the gearbox itself. Then you'll have air movement, and contaminated air can flow in. Now, then this contamination, of course, especially in the gearbox, typically they don't have a filtration system on it. So all that contamination is accumulating there and is causing, of course, more and more problems. And then, of course, again, contaminating new oil and adding the wrong oil, which we see in practice a lot happening. All right, so we now have looked at where this contamination is coming from, and now what we will do is dive into two main contaminants that are particles and water, and what they do to the systems, and what sizes are we actually talking about. So if you look at particle contamination, and what it causes, approximately 80% of the mechanical wear is particle-induced contamination. And the main failure mode is abrasion. And erosion we also see, especially in hydraulic systems, and also fatigue in more in bearings. And how is it possible that micron-sized particles between the 2 and the 10 micron are doing the most damage? Well, first of all, they're there in very high quantities, as we will see in just a bit. But if you look at the chart on the right-hand side, you see that the clearances, let's say in proportional valves or servo valves, are really micron-sized clearances, somewhere between 1 and 6 microns. So if you have a clearance of 4 micron, and you have a 4 micron sand particle, silicon particle coming in between sliding surfaces, it's going to create scratches of the surfaces. And from those scratches, first you get some grooves, and then small micron-sized particles will come loose. So then you have your wear particles, and then of course these will generate more wear. So um, this is basically the reason why those small particles are doing the most damage. What kind of damage? Well, I just talked about it. So abrasion, especially three-body abrasion, when there's a hard particle coming in between two sliding surfaces. Erosion, you can imagine if you have a hydraulic system pumping at 500 liters per minute, 500 bar, that there's a huge on the surfaces, and these small particles are hitting the surfaces, um, 24/7. So again, damaging especially the sides, the port sides. And of course, once the port cannot be closed off properly anymore with the spool, what you will get then is leaking oil. You lose your efficiencies and your productivity, and of course, on the long course, it will completely damage the valve from the inside, and then you have to replace that valve. And fatigue. This is when a hard particle comes in between the rolling element and the bearing body. Um, and then, of course, you can imagine that there's a lot of high forces on the bearing of a pump. There's already so much damage being going on, um, that it ends with such a failure. But it's really not normal that your pump breaks down after a couple of years, or that your gearbox only lasts 10 years. These are high value, high quality products, and these are there to last at least 10, 15, 20, 30 years. All right, so particles. Not sure if you are familiar with the international standard to measure oil contamination, but it's very important that in the world of machinery lubrication, when you talk about oil cleanness levels, that you understand this. I'll just give an example so that you verify, let's say. So the ISO 4406 measures the three sizes of particles. It measures 4 micron and larger, 6 micron and larger, and 40 micron and larger. And you must realize that we can only see from around 40 to 50 micron and larger. So we're talking about something that we cannot see. Onesies, twosies, or thousands of particles. No, it's there in millions and millions and millions. So we have an example. We took a sample and we had it analyzed, and this was a sample in 100 milliliters, just to give you a better representation. But in 100 milliliters, which is, well, just a zip of coffee that you take, that was measured 165,000. Now, try to imagine if you have a system, how many particles there are flowing through your systems. Again, and these are flowing all the time through your system, through the valves, your cylinder, high speeds, high flows. So you can maybe imagine better that of course, if this happens on a daily basis, that it will generate and reduce significantly your service life of your components. Now, just coming back to the 3 digit, so we measured 4 micron, 165,000. You go to the ISO 4406 table, and you see it works with ranges. So this falls under the range from 130 to 250,000 particles, with 18. The 6 micron was around 50, between the 32 and 64, digit 16, and then the 14, just over 5,000, between 4 and. So for this oil, the ISO class was 18, 16, 13, which is, I can tell you, quite a clean oil, but it still has a lot of particles in it. So probably if you take a sample of a system that you will measure something beyond 21, it goes up to 28, but you can imagine how many particles there are in that oil. So as you may have noticed, every digit is a double of particles, right? And here as an example, this is from a ball mill lubrication system in a mine, and we did a filtration job of this oil, and the starting point was a 26, 22, 15, and this is measured in 1 milliliter. If you look at the amount of particles, total amount was more than 450,000. So very difficult to imagine that in 1 milliliter there were so many particles. But so it was a highly contaminated system. We did a filtration job of a couple of hours, and then we brought it down to only just over 45,000. So you see, this is a 90% reduction of particles. However, if you look at the ISO class, there was just a 3-digit difference. So that's important to understand also of the ISO class. Now, what does all these particles do? So of course they reduce the service life of your systems, of your components, but Machinery Lubrication Council did a study, and they did the study on 2 equal setups, and they had to both work on contaminated oil, one very contaminated and the other one, well, a relatively clean oil. And if you look at the left-hand side, so we're running at 250 liters a minute with an ISO 232118, which corresponds approximately to a NAS 12. This means that on a yearly basis, more than 4,000 kilograms of oil or dirt is passing through the pump each year. So, yeah, if you have a system running on this type of oil, you'll probably see that your pump breaks down after 2 years. On the other hand, if you have your pump running on clean oil, in this case a 16, 14, 11, corresponding approx to a NAS 6, you're only pumping 25 kilograms of dirt through the pump, and therefore the expected lifetime of the pump is 40 years, which is somewhere where it should be, right? But you see there's a factor of 7 between operating in contaminated oil and operating in clean oil. So if you then extrapolate this study into relative component life and oil cleanness levels, you see that with a hydraulic system, for be somewhere at 17, 15, 12 or 16, 14, 11. And as soon as that you are operating in contaminated oil, you'll see a significant reduction of your relative component life. But on the other hand, you're actually extending the lifetime of the oil, of the component even more. So there's, in the end, there's no such thing as too clean oil. Consists in 3 states, let's say in the oil. We have dissolved. Oil can hold a certain amount of water, but we're talking around a couple of hundred people. And ideal situation, it will last for years and years. However, what happens in practice, there's a lot of enemies and a lot of items interacting with the oil molecules, and from all these different aspects, you get all kinds of chemical reactions, of which oxidation is the most common one, of course, because anything that interacts with oxygen will oxidize, but also thermal degradation and sometimes microdieseling or hydrolysis. Of course, when you have a lot of water, you have water washing as well, where the additives are washed out of the oil, and of course their capabilities, etc. But it accelerates basically the, degradation we cannot control, like heat and oxygen, and control is make sure that we put in the right lubricant and take out contamination when it's in the system. And that's what we're all about. So contamination control strategy is keeping the oil clean and dry and your system reliable. A strategy starts with consists of three components, three different components, of which setting targets is the first one, then taking actions to achieve your targets, and then, of course, measuring results to see if you are achieving your targets and if you have to take another in it there. Starts with setting the targets. We have come up with, if you look at component supplier being Vickers, Eaton, Bosch Rexroth, you name it, they all have somewhere in their manuals stated what the cleanness level is of certain components to work properly. And if you put them all together, we can come up with a table like this. But as you can see straight away, we're really looking at the 17, 15, 12, or 18, 16, 13, somewhere there, or better, of course, as your targets. So taking the actions to get that contamination control. Now, within the company desk case, we look at all the aspects from the moment at the plant until it's really inside your asset and can be monitored. And it starts basically with the oil arriving at your plant and being stored. So that your loop room doesn't look like something like this, but this is really just a couple of examples, real-time examples of let's say loop storage areas, and of course this is not the way you should treat your important asset. Here you can see on the right hand side, you see an example of a very highly sophisticated loop room, right? Climate controlled, everything, all the different oils, identified properly, color coded, be able to pre-filter the oil, properly stored and protected. So this would be, the ideal situation, but also in some cases it might be a utopia and something that you will never reach. However, there's a big journey between what you have on the left hand side compared to get to the right hand side, let's say. And when we look at the lubricant storage and lubricant handling, there are a couple of main goals. So first, the oil properly, so a point designated area, preferably covered outside of the outside conditions, let's say, not in the direct sunlight, not directly where water, rain can accumulate, etc. Another one, very important, to be able to pre-filter the oil when it arrives at your plant. As you've understood, new oil should be according to the properties and specs, but is 9 out of 10 times already contaminated. So you need to ensure that you can bring the oil to your target cleanness levels, and then identify each lubricant, also very coded. You know, gearbox oil is a gearbox oil. And it's not a hydraulic oil. So to ensure that your lubricators or your people that are involved in they put in the right oil and the right equipment. Color coding is a very, very effective matter to do that. And of course, practice lubrication best practices when handling the lubricants. So some other goals and benefits, of course, when you give your oil some better attention, and you look after it, and you understand that is for a reason, and you start to store it properly, you will see that you have a much more tidy and organized workplace, much safer for the worker. Throughout the plant, and you will see that your equipment it will be working much more efficient and productive, and that you will breakdowns, etc., on your inventory and consumption. So a great money saver and environment enhancer, let's say. Um, yeah, here you see a very nice example on the left-hand side. This was the loop storage, also mechanical workshop. It was a little bit of everything, and they transformed it, dedicated loop room, as you can see on the right-hand side. Well, I don't have to. The picture already tells you the whole story. So yeah, this is what a loop room should look like in the end. Like I said before, any oil lubricated equipment has some kind of connection to the environment because it should be able to breathe. And what we see is that most OEMs don't give a lot of attention to this aspect to protect their assets. So yeah, they do nothing to avoid contamination, particles, and humidity from getting in. And therefore, your first line of protection is a desiccant breather. Of course, it reduces water contamination. It reduces oxidation of components, as you can see here in a couple of examples. And of course, it increases fluid life and much more. So replace those common. What does it do? Well, instead of allowing all the moist and particles getting in, it works as follows. So you connect it to your connection, replace it or replace the OEM breather with its Descom breather. Once your system wants to uh, the air will go through holes that uh, it will change color, and then the dry air that's still contaminated with particles will go through a particle filter, which will absorb the particles and dry. So it's cleaning and drying that contaminated air and avoiding that. Works also both ways. So if you have contaminated or water contamination in your oil, the headspace will also have that contamination. And when your system is breathing out, the breather will also absorb that noise. So actively drying the headspace really depends on the lubricated equipment. Is it the pump? Is it a gearbox? Is it the hydraulic system? But basically, for any size or any type of system, even large storage tanks of diesel or oils, we can offer a breather for that. The next step is view and assess. Now, if you have a lot of gearboxes in your plants, probably you come across this kind of situation. And what happens is that at the attention or enough attention to the environment the equipment will operate in, and what the ambient conditions are, and also allow future asset management or equipment maintainability, because here you really don't see anything. And what studies have shown is that approximately 75% of the failures of gearbox and pumps can be traced back to efficient lubricant. Now, if you have to inspect these type of gearboxes, and you have to inspect them, let's say 100 per day, you can imagine that you're not going to really use a dipstick, as you can see here, because you have to, it's like with a car, you have to take it out, then with a cloth dry it, then put it back in, and then take it out again to check the oil level. So what happens in practice, that it will go unchecked, and well, with the, of course, with the gearbox runs dry. So you cannot see the oil level here. You cannot do a visual inspection of the lubricant real quick. It's not protected with from the contamination in the environment. You're not able to do proper top-offs. If you want to do a top-off, or if you have to do a top-off, you have to open. And you cannot take a proper sample. So, yeah, there's a big necessity to enhance, to improve the equipment maintainability. And the main goals here are that you are immediately able to see the presence of the oil, and preferably also, of course, that it's at the right level, but also the color of the oil, because that can also give you some insights on the degradation levels. You should be able to take a representative sample, and of course be able to do top-offs, etc., without having to open it to. So one of the products we supply is a 3D bullseye, and here you can see the big difference straight away. This is a OEM side glass. Well, here you can really not see the level, and then we've replaced it with our 3D bullseye. Straight away from multiple angles you can see the oil level, and you can also have a look at the oil color, so it gives you some insight on the condition of the oil as well. Other enhancements, of course, sometimes you have the oil level indicator, of course, a desk and breather to protect, quick connects to perform top-off without having to open the equipment to the environment, or to do, and also a sample point with a mini-mesh connection, where you just can go there, take the sample with your vacuum pump, and bring it to the lab. So here you can see the same gearbox as we've seen before properly. Now you can see already straight away the oil level. You can see, have a look at the color. It's protected with a desk and breather, and on the other side there was also a sample point installed. Of course, it depends a little bit on the equipment and on the on yourselves what kind of enhancements you want to make. But yeah, there's multiple solutions and products that we can supply to improve that equipment maintainability. Here, also what happens in practice. So here you see it's completely deteriorated, so you don't see anything. And actually, we had, or one of our clients in South Africa, they had a fire because one of their pumps was running dry, and caused a significant fire. So very, very critical, and big hazard. And here, what also happens in practice, that these vent caps get clogged, and then also you can have temperature buildup, pressure buildup inside your pump or gearbox, and of course this can cause also catastrophic failures. Filter and purify. Well, what we see in practice is that typical hydraulic systems or lubrication systems have some filters, but these are simply not capable to I well to capture those very small particles, because often we're talking about 10 or 20, 25 micron filter elements, which means that everything below that will stay in the system and will increase. So increasing your ISO clearance level. And they're also often not capable to keep up with the high amount of contamination ingress. They don't capture water, etc. So there's a significant need for supplementary filtration, and that's where we come in. Um, Important when we talk about filters is the filter efficiency. And so it's not only about the micron size. You can have a 1 micron or 10 micron filter, but if it doesn't show you the efficiency, then it doesn't tell you anything. Often cheap ratio, and a beta ratio is calculated basically by looking at the amount of particles before the filter and measuring them after the filter. So what is done also during a multi-pass test. But cheap filter elements can have a beta ratio of 2, which is just capturing 50% of the particles, and that's very low. And nowadays, and also our systems, we have beta ratios of 1,000 or even more, which is a efficiency. That's really where, especially with supplementary. So the different supplementary filtration we offer, it really depends on the type of contaminant, the amount of ingress, the rate of ingress, etc. And it's also about achieving a balance between contamination ingress and contamination exclusion or removal. We look at these aspects and then are able to offer you the right solution for each system. One of the main products is offline filtration. Well, how does it work? It basically works independently from the main system. So your main system has its filters, has its pump, etc. We don't touch that. We connect the offline filtration unit to the reservoir, and it does its job by micro-filtering the oil 24/7 and thus cleaning and drying your oil constantly. Of course, we have different configurations and setups. This is example you see here is actually in a vertical roller mill in South Africa, where we had a filtration system on the hydraulics, but also on the lubrication system, different size for a reason, because especially on the lubrication system there was much larger unit. Oh, sorry. Yeah, where do you see our systems? Of course, very high critical and product or productivity critical aspects or systems in the industries. So mining, of course, on the rotary kilns, steel belts, crushers, ball mills, etc. But also in cranes, in for example, port and harbors, paper mills on the different applications within a paper mill, lubrication systems, hydraulic systems, injection molding, of course, where the productivity and the scrap products are, yeah, critical aspects of the system, of the productivity, but also steel and presses, etc. So any application where productivity is important, where of course we're talking about how high value systems that when they break down or when a component of such a system breaks down, that the whole production line stands still. That's where we are very of very high added value. Uh, Another product line I just want to touch is our vacuum dehydration units. Oh, sorry for that. So the vacuum dehydration units are there to remove very high in a paper mill or any other industry where you see that there's a high contamination ingress of water. Um, there we have specifically designed a system that doesn't use consumables. So we use a vacuum dehydration technology where we remove into a vacuum chamber, and at those conditions the water will evaporate and the dry oil will be filtered and then sent back to your system. So very efficiently drying the oil. And again, if you have something, your oil, make sure that you dry it, or like this, make sure that you dry it as soon as possible, because the longer it stays there in your system, the more damage it will do. With filtration, it's very important as well to consider that there's filtration, right? Yeah, often customers and companies talk about, oh, I need to do some mobile filtration, some periodic filtration, but you must realize, as you can see in the right-hand graph, is that when you do periodic filtration, there's basically only one moment that you really have clean oil, and that's when you just finished your filtration job. As soon as you take off your system and stop the filtration, you'll see that there's again buildup of contamination levels in your system. And of course, as long as that contamination is in your system, it can do more damage and will accelerate the wear contamination as well. So yes, doing something is better than doing nothing, and it can be for certain systems. That's you really should be looking at constant supplementary filtration. And then the last aspect is measuring monitoring. There are two things when we talk about oil condition. One is contamination, of course, and the other one is degradation. Now, if you look at the lubricant, it will oxidize, it will degrade over time. But normally this is quite a slow process. But of course, if you have contamination in your system, this will significantly accelerate that process. So the longer the contamination is present, the more damage it will do. But it doesn't mean that contaminated oil is the same as degraded oil. Very often, if you clean the oil, if you remove the water, you will see that the oil is still in good condition and fit for use. So again, you can easily based oil condition-based oil changes, especially if you keep it clean and dry. Um, Oil samples. Not sure if you take any oil samples, but if you take manual oil samples, there's a lot of variables that can influence the quality of your sample. And yeah, in the end, of course, you take a sample, let's say of a half or 200 milliliters, and this 200 milliliters will be analyzed by a lab, but the lab will only analyze a couple of milliliters. So now these couple of milliliters are representing a much higher amount of oil, often a couple of hundred liters to thousands of liters of oil. So very important that you take a manual sample with the proper equipment, with the proper procedures in place at the right place, at the right time, etc. And yeah, it's not so easy said as done. So what we offer there, looking at oil sampling, of course, there's the manual oil sampling, but often with critical applications, you have to ask yourself, taking an oil sample once every 6 months or a year or 3 months, is that really enough? Or should I take more samples or more frequent samples? And well, these are um, uh, situations. Oh, sorry about that. Yeah. So when we talk about sensors, what we offer is a particle counter, portable particle counter, which is perfect solution to actually get a quick and accurate ISO cleanness level analysis on site. So instead of taking a manual sample, bringing it to the lab, having to wait a couple of weeks to get the results, you can connect the particle counter directly to the asset, and so there's very little human interference. So the quality of the sample is much higher, much more accurate, and you basically just press start, and within a couple of minutes you have your ISO cleanness level and moisture level. So if you measure at that point a very high contamination level, you can decide to stop the machine and first get leave the machine or put it back in operation instead of having to wait a couple of weeks to get a result, right? So because in a couple of weeks, already operating in contaminated oil can cause devastating failures. If that is still not enough, then we can also offer constant measuring sensors. And the main sensors we have is the contamination monitoring sensor and our oil quality sensor. And I'll just touch them a little bit more in detail. So a contamination monitoring sensor basically measures constantly. You can actually program it to measure every hour, every minute, or every 10 minutes, or whatever you want. And then it will measure and show the results on your screen, show you the NAS class or ISO class, but it also shows you the particle distribution and will show you 8 channels. So this is, of course, the ideal situation to trend the condition of your oil in respect to particles and moisture.
Hello, Martins.
Yes.
You've got less than 15 minutes.
Yeah, sure. I'm wrapping up here. So This is contamination monitoring. Then how it works? Well, light extinction, sorry, principle. So high resolution LED projects the light onto a photodiode. As a particle passes by, there's a light extinction, and that is then calculated into the size of particles. And of course, the more particles pass by, the more it will measure. So it will give you an accurate size and quantity of particles. The other one, as I mentioned before, there's a big difference between contaminated oil and degraded oil. The oil quality sensor measures the degradation of the oil, so the real condition of the oil, and it will not tell you what is exactly going on. It will measure change. So you tell it, okay, I'm going to measure a Tellus 46, for example, and then it will look in the database and then compare the baseline condition or the baseline profile with the actual condition of the oil, and then will give you a number which will indicate how far the oil is degraded, and it will even tell you how many days of remaining life the oil has. So very accurate sensor, can measure every minute, every hour, whatever you want. So as long as you're in the green, you don't have to even take a sample. But as soon as you get into the orange, you can say, oh, wait a minute, there's something significant going on. I'm going to take a sample, bring it to the lab, and have it properly analyzed to understand what's going on. So it's really a perfect tool or sensor to trend. We also have a moisture sensor in case that you have an application when there's a very high amounts of water ingress constant, and then this is a dedicated sensor for that. How to integrate them? Well, there are a couple of manners to do that. You can certain sensors you can put in your system straight away. Others, like the particle counter, needs flow, and that flow you can generate that with either connecting it to a filtration system or to a contamination monitoring center, which generates its own flow by having its own pump motor combination. So ideal for gearbox, and here you see a couple of examples of filtration units where we have the filtration and the condition monitoring in one doing its job. So that's it from my side. I think we have a couple of minutes for some questions.
Okay. Questions?
Okay, maybe I'll go first.
Yeah.
So, sorry, but in time, thanks for the presentation. And of course, I think it's something we quite relate to, particularly for the contamination control. So it's been something where either online or offline. So